Building a reliable third-party streaming client requires far more than wrapping remote network calls. Echo Music is an open-source Android application built on modern Kotlin Multiplatform foundations, Jetpack Compose, and Android X Media 3. It handles media extraction, native audio downsampling, and catalog bridging in a unified mobile stack.
Inspecting the project repository reveals an ecosystem engineered for complete audio autonomy. Forked and expanded from Simp Music, the codebase isolates core domain rules into dedicated Kotlin Multiplatform submodules while leveraging Android X Media 3 ExoPlayer for gapless audio, customizable dynamic themes, and native background playback. The application architecture separates declarative presentation from media playback and data pipelines. Jetpack Compose UI streams events to coin-injected view models. Audio requests route through Android X Media 3, communicating with the KMP core submodule for data querying, room local caching, and custom native audio processing layers.
Beyond standard network streaming, Echo Music embeds a dedicated C++ digital signal processing engine named VibroFP. This native library performs acoustic fingerprinting, downsampling, and fast Fourier transforms on raw PCM audio buffers to identify tracks locally and support robust audio matching operations.
Inside downsampler.cpp, we observe explicit PCM buffer conversion logic. The engine calculates downsample ratios based on sample rates, channels, and bit widths. It maps signed mono, stereo, and multi-channel streams to optimized reduction algorithms, converting arbitrary wave inputs into standardized lower-frequency PCM buffers for analysis. Bridging native audio data to the JVM, the audio resampler component wraps Android X Media 3 sonic audio processor within a Kotlin coroutine context. It pushes decoded byte buffers through native byte order queues, allocating output byte arrays dynamically while validating coroutine cancellation states on every chunk iteration. YouTube stream extraction faces frequent player parameter changes. Echo Music embeds an AST-based JavaScript solver script directly in the client assets. The engine uses Maria and Astering parser routines to inspect JavaScript AST nodes, extracting required signature transformation functions dynamically without remote API dependencies. Looking directly at yt.solver.core.js, the codebase inspects AST expression statements, variable declarators, and sequence expressions. By matching AST syntax patterns against signature decoders and URI component calls, the client resolves playback URLs dynamically even when upstream player obfuscation logic changes.
Importing playlists from external platforms like Spotify requires fast, accurate fuzzy matching against YouTube music catalogs. Echo Music implements pre-computed character bigrams combined with bounded least recently used caches to normalize titles, stripping regex clutter while preserving high matching accuracy.
In SpotifyMapper.kt, we see a dual LRU cache architecture with bounded size allocations. The object precomputes normalized title and artist bigrams once per track, then executes weighted confidence scoring across title similarity, artist similarity, and track duration deltas to achieve early exit thresholds on high confidence matches. The matching engine calculates a total confidence score using 45% title weight, 35% artist weight, and 20% duration alignment. By isolating string sanitization and bigram generation before candidate evaluation, the scoring loop operates with zero redundant regex executions. Echo Music connects diverse services across local storage and external cloud APIs. The local data layer relies on room databases with version migration schemas, while external integrations include OpenRouter and Mistral for automated playlist generation, SponsorBlock for playback skipping, and Firebase telemetry. Evaluating runtime safety shows strict memory isolation in the native C++ layer, where buffer boundaries and channel counts are validated before bit shifts. Coroutine loops explicitly verify active job state during heavy audio resampling, preventing dangling background threads and uncollected audio chunks during fast track switches.
Architecturally, the modular KMP split and Media 3 integration ensure responsive audio streaming and clear separation of concerns. However, embedding native C++ shared libraries and a JavaScript AST engine introduces build toolchain complexity and creates maintenance overhead when upstream stream schemas change. Echo Music showcases how modern Android engineering can combine Jetpack Compose, native C++ audio processing, and AST stream extraction into a cohesive music client. Check out the source repository to explore the Media3 pipeline and Kotlin multi-platform design patterns.